Hello, grade 7, and welcome to our new lesson, which is angles and lines. This is session 1. Before we start with our lesson, let's review the parallel lines. What are the parallel lines? Parallel lines are two or more straight lines that they don't meet at any point, even if they are extended. Any two parallel lines, we call them parallel if they don't meet at any point, no common points, even if they are extended. Example, in the adjacent figure, D1 is parallel to D2, or we can write using this symbol. D1 is parallel to D2. Now, let's learn how to construct parallel lines. We can construct parallel lines in many ways. Let's discover this new way. For example, let's draw a line parallel to this line. Step 1. We put a ruler on this line. Then we can use another ruler or a set square and put it in such a way it is perpendicular to the first ruler. Then, second step, we fix this ruler and we move the first ruler up or down to any point we want to draw the parallel line. Like this. This is the parallel line. So I have or I got a parallel line to the old one. These two lines are parallel. Here we have a property of the parallel lines. We can draw many parallel lines to a given line. Now we want to explain the Euclidean postulates. We have many properties, starting with the property 1. In the adjacent figure, we have a line and a point A which is outside the line. And I want to draw a parallel line passing through this point to the blue line. How many parallel lines can I draw? From a point A outside a line, we can draw one and only one parallel line to this line. If I draw another one, it will be confounded on this red line. So, through a point outside a line, I can draw one and only one parallel line to this line. This one is similar to property number 1. Through a point outside a line, I can draw one and only one perpendicular to this line. So in this case, UV, as you can see, UV, which is passing through A, it's the only one line perpendicular to X, Y. Now property 2. Look at the adjacent figure. We have two parallel lines. AB is parallel to CD. And if XY also parallel to CD, then we will get that AB is parallel to XY and parallel to CD. So property 2 says that if two straight lines are parallel to the same line, then these two lines are parallel. Property 3. In the adjacent figure, we have AB is parallel to CD. If a straight line D, which is a transversal, it cuts AB at a point, does it cut CD also at a point? So property 3 says that yes, then D will cut also CD at a point. Since D is a line, so we can extend it. If it cuts the first line at a point, then it will cut the second point at a point. So property 3 says that if two lines are parallel, they must be parallel lines. Then every line that cuts the first one, then it cuts the second one. This property is similar to the previous one. We have also two parallel lines. Here the third line is perpendicular. So if I have two parallel lines and I get a third one which is perpendicular to the first, then it must be perpendicular to the second. So this property says that if two lines are parallel, any line perpendicular to one of them, then it is perpendicular to the other. The parallel lines acts like twins. Now property 4. Look at the adjacent figure. We have here D1 is perpendicular to D and D2 is also perpendicular to D. What can you say about D1 and D2? D1 then is parallel to D2. So property 4 says that if two lines are perpendicular to the same straight line, then they are parallel. Whenever we have two straight lines that they are perpendicular to the same line, then these two lines will be parallel lines. Let's make an example. Answer by true or false. If U is parallel to V, we have two parallel lines. And we have that V is perpendicular to W. Then, what do you think? Is U parallel to W? The question is U parallel to W? Of course not, it's false. U is perpendicular to W because the Euclidean property said that if I have two parallel lines, then if any line is perpendicular to one, then it's perpendicular to the other. Then in this case, W is perpendicular to U. It's not parallel to it. W is perpendicular to U. By this, we finished our session. Thank you for watching. Goodbye.